Polynomials. A polynomial is a term of the form ax to the n, or a sum of terms where the a, your numerical coefficient, is a real number and the n is a whole number. We have some special terms for some polynomials. If we have only one term, we can refer to it as a monomial. For example, 3x squared. If we have two terms, remember terms are separated by signs, so this will be one term, two terms. We call it a binomial. And three terms we call a trinomial. 1, 2, 3. All of these can be referred to as a polynomial, and anything with more than three terms is also called a polynomial. Descending order is the standard order that we write polynomials. It starts with the highest exponent and goes down. Let's rewrite this polynomial in descending order. So we want the term with the highest exponent to go first. So our 4x to the 6 should go first. And then we'll go down with the exponents. I don't see an x to the 5th term, so we'll go to x to the 4th term. Then we'll look for x to the 3rd. X squared. And we need to put the plus there. That's a positive 5x squared. The minus 3x. And our constant term will go last. So this polynomial is written in descending order. Our next vocabulary word is degree. The degree of a term in one variable is the exponent. Let's look at an example. Find the degree of 3x squared. This is a term in only one type of variable. The degree will be the exponent. So the 2 is our degree. Next, we have a degree of a term in more than one variable. It is the sum of the exponents. Let's find the degree of a term that has more than one variable. So this term has an x and y, and our definition says the degree of the term in more than one variable is going to be the sum of the exponents. So we're going to add the 5 plus 2 to be 7 for our degree. Next, we have the degree of a polynomial is the highest degree of all the terms. For example, we'll find the degree of this polynomial, which is in more than one kind of variable. So we're going to go term by term. For our first term, more than one kind of variable, we have to add the exponent. So we have a 7 plus 1. Remember, if you don't see an exponent, it's a 1. So this term is degree 8. The next one, we have 6 plus 3 will be 9. The third term, 5 plus 2 will be 7. The fourth term, 4 plus 1 will give us 5. And a constant term has degree 0. The degree for the entire polynomial is the highest of all the degrees of the terms. So the highest will be 9. This will be a degree 9 polynomial. If we look at a polynomial that only has one kind of variable and which is in descending order, you will be able to take your degree from your first term because that will be the highest exponent. So this polynomial we wrote earlier is going to be a degree 6 polynomial. Addition and subtraction of polynomials. Example 1, simplify. So we're going to add these two polynomials together. First, we have to check outside the parentheses to make sure there's no exponent, and there's not. We also check in front to make sure there's nothing to distribute, and there's not. So the first set of parentheses can come off to give us 3x squared minus 4x plus 1. We also check the second set of parentheses. Make sure there's no exponent, which there's not, and nothing out in front, which there's not. So this parentheses can also be removed. So plus 5x squared minus 2x minus 7. And now we're going to just combine like terms. So we'll pick the terms that are alike, 3x squared and 5x squared. You're going to work with coefficients. So those are like signs. We will add and keep the sign. One copy of the variable, exactly like it is. Then we'll do the x terms. And they are like signs. So they're going to add, keep the sign, to give us a minus 6x. And then we'll pick the constants. And they are different signs, so they will subtract sign of the larger. Example 2. In this problem, we're going to subtract the polynomials. So we're still going to check outside the parentheses. So we'll check outside the first parentheses, make sure there's no exponent, which there's not, and make sure there's nothing out in front, which there's not. So the first set of parentheses can be removed to give us 5x squared minus 3x plus 2. Then we'll check outside the second set of parentheses. There's no exponent, but we do have the minus here to be distributed to the parentheses. It's going to apply to every term in that second set of parentheses, which will give us minus 3x squared. And then you have the two negatives multiplied will give you plus 2x and a minus 7. Parentheses comes off. And now we're going to put like terms together. So our x squared terms are like terms. We're working with the coefficients. So we have different signs, subtract, sign of the larger, so positive, keep the variable exactly like it is. Now we'll do the x terms. They are different signs, so we're going to subtract. And sign of the larger will give us a negative 1x or just a negative x. And last, we'll do the constants. Different signs, subtract, sign of the larger. So just on the subtracting polynomials, you just have to be careful. Take the time to distribute that minus to that second set of parentheses.